Okay, in this lecture we're going to talk about rational inequalities, just a more difficult level. Again, you'll know that a rational function or expression has a polynomial divided by a polynomial. So in this case here, we are looking at this rational expression here to be, say, less than some value, okay, and we standard form we try and make sure there's a zero over here, okay, to start with, and or we could of course have greater than or less than or equal to or greater than equal to as well. Right, so this kind of form, so the best way to demonstrate this is use an example. Let's suppose I want to solve, and we'll keep this one a reasonably simple one. Let's suppose I want to solve 6 divided by x take 3 is greater than or equal to 4. Right, now the first thing your inclination would be is to multiply both sides by x take 3 and then solve for x and things like this. Well, don't do that. Because remember, x take 3 is an unknown. And we don't know whether it's positive or negative. If it was negative, then we would have to switch this inequality. If it's positive, then it would stay the same. And so we don't know, so we can't do that. So the first step, all right, step 1, is to get this 0 like we said here. Now to do that, we need to subtract 4 from both sides to get this, and then use a common denominator like this. All right, and so what we end up with is x take 3 on the bottom, and we have a 6 subtract 4 by x take 3 here is greater than or equal to 0. And this implies then that if I do this, it's going to be 6 subtract 4x plus 12 over x take 3 is greater than or equal to 0. Or, if you look at this here now, we're going to have a 18 minus 4x over x take 3 is greater than or equal to 0. So that's our first step, is to get it into this particular form, which is a kind of standard form. All right, now step 2. It's a little bit more difficult than the quadratic case, but it's somewhat similar as well. We have to identify certain intervals. Now the first thing is we look at the denominator. All right, note, all right, from the denominator, we know that x take 3 cannot equal 0. So in other words, x cannot equal 3. That's the first thing. So notice that we're omitting 3. We can't have 3 in our solution. Okay. All right, next. All right, we look at when is this equal to 0. So next we're solving. All right, 18 minus 4x, all right, is equal to, let's make it equal to 0. This implies that 18 is equal to 4x, which implies then that 18 on 4 is equal to x, and this would be 9 on 2, so x is equal to 9 on 2. All right, so we have some significant values here, basically. Okay. We can't have 3, and notice that we have that 9 on 2, it's equal, when x is equal to 9 on 2, I get equal to 0. Okay, so step 3 now is like our quadratic type, right, is that we look at the intervals that we've got produced here. So let's suppose here's 0. Right, notice we can't have 3. 1, 2, 3. So I can't have that. I'm going to put a hole there like so, to say that we can't have that one. Right, now we can have 9 on 2, which is 4.5. So here's 4, here's 5, and so I'm going to put a dashed line here, and if you like, a dashed line here. So notice I now have 3 intervals to check. Right, check the intervals, or the truth of the intervals. Right, now first of all, when x is equal to 0. Okay, so we come up to this very first one again, and we say, what happens when x is equal to 0? Well, I'd have, all right, when x equals 0, okay, I'd have 6 on negative 3. Is this greater than or equal to 4? That's what I'd like to know. Well, this would be negative 2. Is negative 2 greater than or equal to 4? No. So this is false. Okay, so that's no good. So that's not going to be true at all. Okay. All right. What about when x is equal to 4? I'd end up with 6 on 4 take 3. Is this greater than or equal to 4? Well, I'd have 6, and that's greater than or equal to 4. Yes, it is. So that's true. So this one is a good one, and this one is not a good one. What if I use 5, x equals 5? Then I'd have 6 on x take 5. Is this greater than or equal to 4? Well, I'd have, that's a 3 there and a 5 here. I'd have 6 on 2. Is this greater than or equal to 4? No, we'd have 3 is greater than or equal to 4. No, this is not true. This is false. So we have, that one's not in. So here's our interval. Now notice we can't have 3, okay, but we can have 4.5. So our solution is we can't have 3, so we use a curved parentheses, and we can have 9 on 2 or 4.5. So I'd have that, and that would be our solution. Right, so that's how we do an inequality like that. Now they get a little bit more complicated, but the process is exactly the same. Sometimes the most complicated part is just getting it into this form with a 0 on the other side. And this requires your algebraic skills. After that, it's the same thing. All right, step 2, first of all, find when the denominator is equal to 0, because that produces a value we can't have. Next, solve when the numerator is equal to 0, and that will give us maybe one value or two values depending whether we have a linear. Notice in this case we had a linear equation on top, or a linear form on top, but we may now get quadratic forms, so we may want to solve that for when that's equal to 0, and we'll get two values here, so we'll end up with 4 parts to this number line, so 4 intervals to the number line, and we'd have to check 4 points and find which ones are true and which ones are false. But the process is exactly the same.